Our next topic is energy stored in electrical oscillator. Energy stored in electrical oscillator. As you know, we are studying electrical oscillator. We know that electrical oscillator is consisting of L and C, that is capacitor and inductor. So, net energy stored in the electrical oscillator is energy due to capacitor plus energy due to inductor, because this is capacitor and this is inductor. So, the total energy is the sum of energy stored in capacitor as well as energy stored in inductor. Now, we will find separately first EC then EL. So, first energy stored in capacitor. So, you have already studied this article in the lower class, that is energy stored in capacitor. So, we know that energy is nothing, energy is the work done stored in the capacitor. So, energy is dW, small work done, and integral of work done is total work done. That work done is stored in the form of energy. So, EC is equal to this. So, what is work done? We know work done is voltage into charge, VdQ. You have already read that dW is equal to V into dQ. And what is V? Since V is equal to Q by C in case of capacitor, you know that V is equal to Q by C. So, here we will put the value of this V, that is Q by C into dQ, and the integral of this Q into dQ, because 1 by C is constant, it will come out, and integral of Q is Q square by 2. So, half Q square by C. This is the energy stored in capacitor. We know that in case of oscillator, the value of Q is the function of sine or cosine, because it is harmonic function. So, Q may be taken as Q naught into cos of omega t. So, I have taken this Q as Q naught, maximum value of Q, into cos of omega t. So, I have used this cos because it is a harmonic function. Therefore, this energy stored is energy stored in capacitor will become EC is equal to half into Q square, means Q naught square cos square omega t over C. So, this is first equation, or energy stored in capacitor. Similarly, we will find the second part, that is energy stored in inductor. Again, we know that energy stored in inductor is EL, and it is integral of dW, and dW is further equal to voltage into dQ, VdQ. But the value of voltage is different in case of inductor. So, in case of inductor, voltage V or EMF is equal to minus L di upon dt. So, you have read this formula in induced EMF or voltage produced in case of inductor. So, V is equal to minus L di upon dt. This is Faraday law. So, we will put the value V here, that is L di upon dt, integral into dq. So, this dq by dt become current. You know that the rate of change of charge with time is current. So, it is integral of L into I into di. L into this is I and it is di. So, we will omit this negative sign because we are considering only its magnitude energy. So, omit negative sign, you can omit this negative sign, or you may use this work done is in the form of negative sign. So, negative into negative become positive. So, we will take only negative sign is omitted. So, this is formula. Now, the integral of this I di is I square by 2 because L is constant, it will come out, and integral of I is I square by 2. So, it is half E L is equal to half L I square. This is. Now, again we are using simple harmonic motion equations. So, I, because you know that this I is written as half L dq by dt, because current is dq by dt, and q is q naught cos omega t. Again I have used this equation for harmonic oscillator. So, we will put this value q here, dq by dt. So, dq by dt become, this will q naught, and integral derivative of cos omega t is minus sin omega t into omega. So, it is minus q naught omega into sin omega t. So, putting the value of dq by dt where, and energy stored in inductor EL become half L into dq by dt is this, that is minus q naught omega sin omega t whole square. So, on squaring we will get this EL is equal to half into L into minus square is plus and q naught square into omega square into sin square omega t. So, this is equation number 2. So, equation 1 is energy stored in capacitor, second energy stored in inductor. Now, we have already used the formula omega square is equal to 1 by L C, since in the previous article I have used this formula or put this formula 1 by L C is equal to omega square. So, you can replace this C, means 1 by C, 1 by C become L omega square. So, you can put this 1 by C as L omega square. Now, E C become, so I have modified equation number 1 little bit, that is half into q naught square into cos square omega t into 1 by C. 1 by C is L into omega square. So, it is half L q naught square into omega square into cos square omega t. This is first A equation, that is extension of first equation, that is first A. So, why I have used this formula? Only to find the value of EC like as EL. Now, if you compare this equation number 2 and 1A, then you will observe that the equations are very similar to each other, half L q naught square omega square, and here it is sin square omega t, it is cos square omega t. Now, find the total energy. Therefore, total energy is the sum of EC and EL. So, putting these value of EL here, EC here, and you will get this EC. What is EC? Half L q naught square omega square into cos square omega t, EC, and what is EL? It is again same, half L q naught square omega square into sin square omega t. So, taking common, half L Q naught square omega square is common, and it is cos square omega t plus sin square omega t. We know that the value of cos square omega t plus sin square omega t is 1. So, it is half L Q naught square omega square. This is total energy stored in the electrical oscillator. So, this formula is same as we observed the formula in mechanical oscillator, that is half m x square into omega square or a square. So, this is total energy. Again, if we plot the graph of these energies, then you will get the same answer, that is energy is here and time is here. For capacitor, it is cos square, this function is cos square, and it is sin square, and ultimately it is constant. So, one function is like this, other is like this, and total is like this. So, same type of graph has been observed in electric oscillator as well as in mechanical oscillator. So, this is a variation of energy stored in the electrical oscillator. Thank you very much.